Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today's lesson is about trigonometry, one of the chapter in P3. The subtopic that I'm going to teach today is about how to express the trigonometry into r sine x plus minus alpha or the r cos x plus minus alpha. Usually you'll be given two different trigo here, and the question will actually ask you to express these two different trigo into one trigo. It's either in the r sine or r cos x plus minus alpha form, where the alpha must be in between 0 to pi over 2 or 0 to 90 degree, which is in the first quadrant, and the r must be more than 0, which is a positive value. So how are we supposed to find out the r and the alpha here? If you refer to the textbook, the r you can actually find by square root the a squared plus b squared. And for the alpha value, you can find out by finding the arctangent of b over a. This is a fixed formula. However, I don't really recommend this method because this might cause some confusion if the coefficient of the sine and cos here, the value of a and b are interchanged. Then your alpha here will be wrong. So what's the proper method to find out the r and the alpha? We shall do it in the long way instead of using the formula. So let's ignore this formula. I'll describe the method by using the example. Have a look at this example, the year 2019, October-November paper, variance 32. For the part 1, you are asked to express the square root 6 sine x plus cos x in this form, the r sine x plus alpha form, where the r must be more than 0 and the alpha is in between 0 to 90 degree. And then you're asked to state the exact value of the r, and the alpha must be correct to 3 decimal places. For the part 1, when you are asked to express these two trigo into r sine x plus alpha, then you just need to let square root 6 sine x plus cos x equate to r sine x plus alpha. And then the next step, you will just need to expand the right hand side by using the compound angle formula, which is sine x cos alpha plus cos x sine alpha, and the r is supposed to multiply into both of it, which gives you r sine x cos alpha plus r cos x sine alpha. So what to do next? We need to compare to the left hand side. Let me jot down the left hand side, which is square root 6 sine x plus cos x. So we just need to compare the first term with the first term, which is this and this. You notice that for the sine x, the coefficient is just square root 6. And for the right hand side, the sine x coefficient is r cos alpha. So you just compare the coefficients for the sine x. Then from here you can actually form one equation. The next one, you will need to compare the coefficient for the cos x. So for the left hand side, the coefficient is just a 1. And for the right hand side, the coefficient will be r sine alpha. From here, we'll be able to form two equations. Then you just need to solve simultaneously to get the value and the r. But to be easier and to leave your answer in exact form, it's actually you just need one extra step. You need to rearrange to get cos alpha in terms of the r and the numbers, which is square root 6 over r. Same goes to the sine alpha, is equals to 1 over r. According to this trigo ratio, we can actually build a right angle triangle and name one of the angle as alpha. So according to cos alpha is equals to square root 6 over r. Sine alpha here is a 1 over r. So 1 should be placed at the opposite side. Okay, this is our right angle triangles ratio. So according to this, we can actually find out the r by using Pythagoras theorem, which is square root 6 square plus the 1 square. And hence you get a square root 7, an exact value. That's why the formula, according to the formula that I mentioned earlier, is square root of a squared plus b squared. It actually comes from this method. As for the alpha, you can actually find out the alpha by using tangent. Tangent alpha is equals to 1 over square root 6, and that is why alpha is equals to arctangent 1 over square root 6, and hence you will get the answer of 22.2. And according to the questions, they want the answer correct to 3 decimal places, so it's 207. Oh no, it's 208 degree. That's your alpha's value, and hence we can leave our answer in the form of, remember this form, r sine x plus alpha, and therefore you can leave your final answer in square root 7 sine x plus 22.208 degree. This will be the final answer. As for the part 2, have a look at the part 2 here. Part 2, hence solve the equation. When you look at the word hence, means is related to the part 1. So you notice that this equation, the left hand side, is exactly the same here. Let me highlight it. This and this looks the same, except for the 2 theta. The x is changed into 2 theta. So to solve this equation, we can just make use of the part 1's answer, but remember to change the x into 2 theta and equate the whole thing to the 2. So for the part 2 here, what we need to do is just to take the expression from the part 1 and equate it to 2. So just copy back the expression, but remember to change the x to 2 theta and equate the whole thing to 2. Then from here we can start to solve to get the value of the theta. So sine theta plus 22.208 should be equals to 2 over square root 7, and therefore you just need to press the calculator to get arcsine 2 over square root 7, and you will get the basic angle of 49.1066, and the other angle will be just the angle in the second quadrant, as here you notice that it's a positive value. So when sine is positive, the answer should be from the first and second quadrant. So the other answer should be 130.8934 degree, and hence you can eventually get the final answer as 13.4 degree and 54.3 degree. This is how we solve for the part 2. Let's have a look at another example, the recent years example, the year 2018, paper October-November, variance 31. Have a look at the part 1. Show that the equation square root 2 cosecant x plus cotangent x is equals to square root 3 can be expressed in this form: r sine x minus alpha equals to square root 2, where the r must be more than 0 and the alpha must be in between 0 to 90 degrees. This question actually looked a bit different from the previous year's questions because you are asked to express cosecant and cotangent in this form instead of sine and cos here. So what should we do now is to express this equation in terms of sine and cos. So for the part 1, let me jot down the question. We are supposed to rearrange this equation in terms of sine and cos only. So for the first part, you should change it into square root 2 over sine x. Second part, plus the cos x over sine x equals to square root 3. Then you just need to multiply every term by sine x, and you get square root 2 plus cos x equals to square root 3 sine x. Then what to do is you have to rearrange it into this form. Something equals to square root 2. And therefore, we will have square root 3 sine x minus cos x equals to square root 2. And then you just need to compare with this equation. And you will find out that the left hand side square root 3 sine x minus cos x is actually equals to the r sine x minus alpha. Then this will go back to the question that I taught you earlier. You just need to compare the coefficients of the sine x and the cos x. So for this question, if you use the formula to get the r and the alpha, then you're going to make sure that the a and the b, which is the coefficient of the sine x and the coefficient of the cos x, is arranged properly. So if your a and b are interchanged, then your alpha will be wrong. That's why I will suggest you to use this method. Expand it for the right side. After expand, you will get r sine x cos alpha minus r cos x sine alpha. And then when you compare to the left hand side, remember I mentioned this term, first term compared with the first term, second term with the second term. So for the first term, after comparing, you notice that square root 3 is actually equals to r cos alpha. For the second term, the coefficient of the cos x is 1. For the right hand side, coefficient is r sine alpha. So you just need to express cos alpha in terms of r and the sine alpha in terms of r as well. Then from here, you just need to have a right angle triangle, alpha here. So according to the cos ratio, square root 3 should be here, r should be here, and for the sine alpha's ratio, the opposite side should be a 1 over the hypotenuse r. So from here, we can find out the r value is square root of square root 3 square plus 1 square, which is 2. And for the alpha, it should be, we will need to take tangent alpha equals to 1 over root 3. And therefore, the alpha should be equals to 30 degree. Whether the angle you need to leave in degree or radians, it depends on the question. Look at the question here, it must be in degree. So the answer is just 30 degree. Alright, have a look at the answer here. R is 2, alpha is 30. Alright, so it's correct. As for part 2, for the part 2, hence, again, is related to the part 1, solve this equation. So this equation cannot be solved, and that is why in the part 1 they ask you to express in this form. So which means instead of solving this equation, we can just solve this equation. For the part 2, we can just use the values that we have found out in the part 1. The R is a 2 and the alpha is a 30. So we can write our equation in this form. 2 sine theta minus 30 degree equals to square root 2. So sine theta minus 30 degree should be equal to square root 2 over 2, and hence the basic angle should be equal to 45 degree. Since the sign here is a positive value, which means the answer should be from the first and second quadrant. So the next answer should be 135, which means the final answer here should be just equals to 75 degree and 165 degree. This is how we solve for this question. And that is all for the lesson today. Thank you.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.